section 12.5, we're going to be talking about multiplying polynomials. So just general directions before we get started. When distributing, remember the product property. Of exponents. And just in case you don't remember, it says if you're multiplying the same base, you add the exponents. So x squared times x to the third is x to the fifth. And then we use the commutative property to rearrange order. So the commutative property tells us that like 2xy is the same thing as 2yx, which is the same thing as x 2y. So the commutative property just tells us that when we're multiplying, order doesn't matter, and that's just going to help us throughout these problems. So you'll see as we work through it. Main idea from the directions is if you're multiplying the same base, we add their exponents. So let's multiply. So if we had negative 3x squared times 4x squared. Our commutative property says we can rearrange the order, so we could just do negative 3 times 4, and then x squared times x squared. That's the commutative property that tells us order doesn't matter. And this will just be negative 12x to the fourth, because we're adding exponents because we're multiplying the same base. What if we had 1/2 x to the third times negative 2/3 x to the fifth? Just give me a second. I want to see if you can multiply that. Well, just like before, we could just do 1/2 times negative 2/3 times x to the third times x to the fifth. When you multiply fractions, we just go straight across. But like 1/2 times 2/3, you just multiply the top numbers and the bottom numbers. This would just be 2/6 or 1/3. Right? That's how you multiply fractions. This would just be negative 2/6. X to the 8, and then we could just reduce. This is negative 1/3 x to the 8. All right. What if we had 2x times x squared minus 3x plus 4? The way we do this is similar to what we did before. Remember how we put a 1 in front and then distributed it? That's the same thing we're going to do here. We're going to distribute the 2x. So we're going to do 2x times x to the second plus 2x times negative 3x plus 2x times positive 4. So it's kind of like the previous two examples. And then when we're multiplying the same bases, of course, we add. Remember, x is really x to the first. This is just 2x to the third minus 6x to the second plus 8x. That would be the answer. Also, just so you know, this is called standard form. Standard form just means the highest power, next highest power, go to the set order. Keep doing this here. What if we had 2x squared y times 3x to the third minus 4xy plus 2y squared? Similarly to before, we just distribute. And this is just going to be 2x squared y times 3x to the third plus 2x squared y times negative 4xy plus 2x squared y times 2y squared. Again, we could rearrange the numbers. When we're multiplying the same letters, what we do is we add their exponent. This is going to be 6x to the fifth y minus 8x to the third y squared plus 4x to the second y to the third. 1 plus 2 is 3. Stop me if I say something that doesn't make sense. Are we doing okay so far? Let's change it up a little. What if we had x plus 2 times x minus 4? Kind of like before, but what we're going to do is we're going to distribute x times everything. And then we distribute the 2 times everything. So we're going to do the x first, x times x plus x times negative 4. And then we're going to distribute the 2 times everything, 2 times x plus 2 times negative 4. X times x is x squared minus 4x plus 2x minus 8. This is just x squared minus 2x minus 8. Make it a little more advanced here if we did this. 3x squared plus 1 times 2x minus 4. We'll do the same thing. We'll distribute like we did before. And then distribute the 3x squared times everything, and then the 1 times everything. We'll just multiply. 3 times 2 is 6, x to the third, minus 12, x to the second, plus 2x minus 4. This one is always a little tricky here. If we had like 2x plus 1 to the second power, it's really bad if you do this. 2x plus 1 and you distribute the 2. That's bad. Please don't do that. All right. On my test, I get partial credit unless you do something like that. That's a really, really bad thing. You could do that if you are multiplying on the inside, but not if you're adding or subtracting. Okay. For a problem like this, what we have to do is 2x plus 1 times 2x plus 1. And then it's the same as all the other problems. 2x times 2x plus 2x times 1 plus 1 times 2x, and then 1 times 1, which is 4x squared plus 2x plus 2x plus 1, or 4x squared plus 4x plus 1. And then one more of these. What if we had x plus 2 times x to the third minus 4x plus 1? So the difference with this, obviously, is we have binomial times trinomial. But in math, the steps are exactly the same. The only thing that changes are the numbers. So just like before, we're going to multiply x times everything. Then we're going to multiply the 2 times everything. So x times x to the third plus x times negative 4x plus x times 1. Then we multiply the 2 times everything. This will be 1 plus 3, so x to the fourth minus 4x squared plus x plus 2x to the third minus 8x plus 2. And then just combine like terms, and we want to put our powers in descending order. So x to the fourth is the biggest, Then we have x to the third. And we have x to the second. Then we have our x. And then the 2. Last problem for this section just says to find the area. Remember, area is equal to just length times width of a rectangle. So we have a rectangle here. The width is 2x minus 3. And the height is 4x plus 5. So it's kind of the same thing we've been doing, but technically it's like an application. So the area is equal to the length times width. So 2x minus 3 times 4x plus 5. Doesn't really matter what you label the length or which one's the width. And then we're going to finish it just like we did the other problems. We're going to distribute the 2x times everything. And then the negative 3 times everything. This is 8x squared plus 10x minus 12x minus 15. And combining our like terms gives us 8x squared minus 2x minus 15.